Hi everybody. This is the last video to go along with section 12, which is on systems of linear equations. So first, let's define what that means. A system of linear equations is when you're solving two linear equations at the same time. The answers are going to be points of intersection. So that means that all answers to systems are going to be ordered pairs or some set of ordered pairs, because you're talking about points on a graph. We're going to focus on solving systems using a combination of algebra and graphing. There are other algebraic techniques out there, mostly substitution and elimination. You might have learned those in previous courses. We're not going to be learning them in this class, but if you already know how to do them, you are totally free to use any technique that's going to help you get the answer. Or if you want to see one of them, I'd be more than happy to show you. But I want to focus on just one way to get you guys ready to solve systems. So let's think of something that we already know. We know that we can't extract any important information about the line unless it's solved for y. So we want to get y equals, okay? Our calculator only understands in y equals, so we want to get it in y equals. So that's going to be our first step no matter what. All equations need to be solved for y first. That's got to be our first step no matter what. So there's three possibilities that can occur. Possibility number one is that the equations come out looking exactly the same. So if they're exactly the same equation, then that means they'll be the exact same line. And if you graphed them, they would be directly on top of each other because you'd be graphing the same line. That means that all of their points are shared. They're all intersection points. And so you would have infinite solutions. Algebraically, we saw infinite solutions because the variables cancel out and you'd be left with something that's true, and it's always true no matter what. And so we would have infinite solutions. If you remember, you would have the option to write either infinite solutions or all real numbers. Now we're going to focus on infinite solutions because you're talking about two. You're talking about an x and a y, so a set of ordered pairs. So we're going to say infinite solutions. Possibility number two is that you solve each equation for y, and the equations come out with the same slope but different y-intercept. That means that the lines quote-unquote start at different points because they have different y-intercepts, but they're going to move in the same direction. Now, if we were live, I'd be demonstrating this in the front of the classroom. Imagine that I'm standing at one point somewhere in a room, and someone else is standing a few feet away from me. If I gave us the same set of instructions, and I told us to go up one and to the right two, and that's how we continued to move, we're never going to cross paths. We're never going to bump into each other because we'd be moving in the same direction. That constant slope, that same slope, is causing us to move parallel to each other. And parallel lines, by definition, do not cross. So if parallel lines never cross, there's going to be no solutions to that system because there will be no points of intersection. Algebraically, you'd wind up with the variables canceling out, just like we saw in the algebra sections, and you'd be left with something that's totally false, makes no sense, so there's no values that would ever make it true, and that's how algebraically you would get no solutions. So, same thing that we saw in algebra. And then possibility number three is that the equations are totally different, they intersect at one point, and then we have to find that intersection point. And this is the most common one, okay, that the two graphs cross somewhere. So now let's look at an example of all three. Before we look at the example, let's just summarize really quick. That's why I put this in bold. Linear systems have three possibilities. There's going to be no solutions, which means the lines are parallel, or there's going to be one solution, which means the lines intersect, or there's going to be infinite solutions because they're the same exact line. And when you're talking about two straight lines, These are the only 3 orientations that could potentially happen. So now let's look at the examples. Here's a system, negative 3x plus 2y equals 1, and 6x minus 4y equals negative 2. First thing we have to do is get them solved for y. Get y by itself. So here's the work for getting the first equation solved for y. You can see in small writing, I put what the step was so that you could follow the algebra. So the first thing we had to do is add 3x to both sides. That leaves us with 2y equals 3x plus 1. Then we have to divide everything by 2. So across the board, we have to divide by 2. And that gives us y equals 3/2 x plus 1/2. Then we have to do the same thing for the second equation. So we had 6x minus 4y equals negative 2. Subtract 6x from both sides. Why do we subtract 6x? Because we have to move this whole chunk of the equation. And since it's positive, the only way for me to get rid of it is to subtract it. So we subtract 6x from both sides. Then we have to get rid of this negative 4 that's in front of the y. So we have to divide by negative 4 across the board, everything. Keep in mind you're dividing by a negative, so the signs are going to change. That's going to leave you with y equals 6/4 x plus 2/4. But I can simplify those fractions, and I get y equals 3/2 x plus 1/2. You can see that you wound up with the same exact equation. There's no point in even graphing this. We're going to get the same exact line. They're going to share all the points, and so there's going to be infinite solutions. If you wanted to show the algebra, but again, it's not really necessary because you can see what's going to happen, you would set the 2 equations equal to each other, and then when you try to solve algebraically, you would subtract the 3/2 x, but they would cancel out. And I'd be left with 1/2 equals 1/2. Well, 1/2 does equal 1/2. There's nothing wrong with that. It's always going to be true, which means there are infinite solutions. Now let's look at the second scenario. There's another system. Y minus 1 equals 2x, and 2x minus y equals 5. Again, get y by itself. So in the boxes are the math for getting each equation by itself. So for this one, all you have to do is add 1 to both sides. So you get y equals 2x plus 1. Here, first you have to subtract 2x from both sides, but that leaves you with negative y equals negative 2x plus 5. I have to get rid of that negative, so I have to divide everything by negative 1, and that's going to change all the signs. So just be careful of your signs. That's going to leave us with y equals 2x plus 1 and y equals 2x minus 5. They both have the same slope. The slope is 2 in both of those cases. But the first one has a y-intercept of 0, 1. And the second one has a y-intercept of 0, negative 5. So they quote-unquote start at different positions on the graph, but they're going to move in the same direction. They're going to move up 2 over 1. So that's going to be parallel movement. Those 2 lines are going to be moving parallel to each other. If you don't recognize it from comparing the 2 equations, you can graph them. If you graphed these 2, you would see that they would run directly parallel to each other and never cross. And if they never cross, there are no solutions. If you were to do the algebra, you would set them equal to each other. So 2x plus 1 equals 2x minus 5. And when you go to solve it, you would subtract 2x from both sides, which would leave you with 1 equals negative 5, which makes no sense. 1 can't equal negative 5, so there are no possible solutions. So now let's get down to the one that is the most common one. Solve the system x plus y equals 3 and 2x minus y equals 0. So again, first step is get y by itself. So in both of these boxes, I have the work for solving for y. These are not as complicated as the ones above, So hopefully you can just read through the steps. You wind up with y equals negative x plus 3 and y equals 2x. You can see that they are totally different equations, and so we're going to be solving them algebraically and graphically. Algebraically, I'm going to set each equation equal because I want to know when these two things are going to cross each other. So I'm going to set negative x plus 3 equal to 2x. And then I'm going to do some algebra. So I'm going to add x to both sides. Leaves me with 3 equals 3x. Divide by 3. And so I get x equals 1. Remember, one single number is not your answer. You have to have an ordered pair. So you have to then take this x value and plug it back in to one of the original equations to get y. So I just chose the first one. You could have chose either one. I just happened to choose x plus y equals 3. So I took the first equation, I substituted 1 in for x, since that's what I got, and I found out that I get a y value of 2. So the point 1, 2 is a point that they both share. So that tells me that the solution to the system is the ordered pair 1, 2, and I can check it by plugging it in to the second equation and making sure that that works out. So you guys, you can try that on your own. Now let's see how we're going to do this graphically. So the way you're going to do this graphically is you plug the two y equals equations into whatever technology you happen to be using. If you have access to a graphing calculator, great. Maybe you're able to get the emulator. If you don't have access to a graphing calculator, we're going to be looking at Desmos in this video. So you can always use Desmos or some other graphing software. There's some other things out there. GeoGebra is another graphing software. These are all free. All you have to do is go to their website. And then the graphing calculator makes you think a little bit more. So on the graphing calculator, you would have to set an appropriate window. So you have to be thinking about that, where you would have to see the two graphs intersect. And some of the other software, it's going to kind of do it for you. So there's less thinking involved. So that's one reason that I'm not a fan of moving to some other technology, but we're going to work with what we have. So I'm going to demonstrate Desmos. And then once you have them plugged in to whatever you're going to be using, you simply find the intersection point. You know how to do that on the graphing calculator, because I did that on the last video. So that's second trace, and then choose number 5 and follow the prompt. On Desmos, really all you have to do is click on that point where they intersect, and it's going to give you the answer. So there's really no other steps involved. It's actually pretty straightforward. So I'm going to demonstrate Desmos, but I also want you to realize that we know how to plot using the the y-intercept and the slope. So you could always plot by hand and then kind of verify that they are crossing at the point that you're getting algebraically. So I just want you to always keep that in mind too. You have the tools to do this without technology. So don't forget about that. So now let's take a look at Desmos. So this is what Desmos looks like. It's desmos.com. Okay, this is what it's going to open. So just desmos.com. And I'm going to put in the two equations that I had, which were y equals negative x plus 3. I don't even have to type in the y equals. I just type in negative x plus 3. Notice that it graphs it just automatically as I'm typing. And then I'm going to hit enter. That's what I want for my first graph. And then I wanted 2x for my second graph. And notice how it automatically plots it. All I have to do is go to the graph and click on that point, and it's going to tell me what it is. So that point of intersection is the point 1, 2. So it verifies my solution. that I got algebraically. So that's how easy Desmos is. We're going to do another one together and then verify it with Desmos, just so you can see it again. But it's going to just pop up with the answer. So it's pretty neat. All right. So let's try another one together to make sure that we've got this. So let's open a whiteboard and try a brand new one together. Let's solve x plus 2y equals 1 and 2x minus 3y equals 9. First thing we have to do is get y by itself. So I'm going to take x plus 2y equals 1, and I have to get y alone. So take away x from both sides. That's going to leave us with 2y equals negative x plus 1. Divide everything by 2. And that's going to leave us with y equals negative 1/2 x plus 1/2. Now take 2x minus 3y equals 9. Get y by itself, so minus 2x from both sides. That leaves us with negative 3y equals negative 2x plus 9. Divide everything by negative 3. Pay attention to the sign change. A negative divided by a negative is a positive. And then a positive divided by a negative is a negative. So you wind up with y equals 2/3 x minus 3. These two equations you want to set equal to each other. So we're going to go to a new screen so that we can set these equal and practice our algebra. So we want to set equal negative 1/2 x plus 1/2 equals 2/3 x minus 3. This is going to be a nice reminder of how we get rid of fractions in our algebra. So a nice refresher. The common denominator among all the fractions here would be 6, because these all go into 6. So I'm going to take this whole side and multiply by 6. And I'm going to take this side and multiply by 6. Everything has to get multiplied by 6. You can put 6 over 1 if that makes it easier. So this is negative 6 over 2 x plus 6 over 2 equals 12 over 3x minus 18. All of these will simplify. Negative 3x plus 3 equals 4x minus 18. And now perform the rest of the algebra. Add 3x to both sides. That's 3 equals 7x minus 18. Add 18 to both sides. That leaves us with 21 equals 7x. And last but not least, divide by 7. And so x equals 3. But remember, x equals 3 is not the only answer. So we want to be able to take this x equals 3 and plug it back into one of the original equations. So one of the original equations, let's go to a new screen. The first original equation was x plus 2y equals 1. And now I want to know what happens when x equals 3. So when x equals 3, I'm going to substitute 3 for x. I'm going to solve this. Take away 3 from both sides. That leaves me with 2y equals negative 2. And then divide by 2. And so y equals negative 1. So I just found out that these two graphs should intersect at the point 3, comma negative 1. Now we're going to use Desmos and see if that's true. So we're going to verify this graphically. Okay, so let's go back to Desmos and verify this graphically. We're going to close these out so we can start new. And we want to make sure that -1/2, move the cursor over so that you can type the x next to it, plus 1/2, enter, and then 2/3, move it over so that you can type the x next to it, -3. Now just go over to the graph and click, and it's going to give you that point of intersection. So the point of intersection is 3, -1. Makes me feel better about my algebra. So that's a little bit of Desmos, and that's how you're going to solve systems of linear equations. So I hope this made sense. And if you have any questions, just let me know. And I hope you all have a wonderful day.